Hi, welcome back to example 3 for 5.1, modeling periodic behavior. In this example, we're going to look at natural gas consumption in Ontario. So in this graph here, our y-axis, we have thousands of cubic meters. That's how we measure the volume of gas that is used. And then on the x-axis, we have our months starting from January 2001. Okay, so 12 months would represent 1 year, and then another 12 is 2 years, 3 years, 4 years, 5 years. So this is a 5-year period showing residential natural gas consumption. Okay, so it says explain why the graph has this shape. So why should it have this shape? That's going up, down, up, down, up, down. Okay, and repeating. And it's almost, they're not exact, but they're fairly close, right? Well, it makes sense that it repeats because Ontario's weather also repeats. So we can see that gas consumption is really high at the start of the year. So January is the month start, so it looks like it's probably February where we're at the highest value. And then it starts to go down as the weather warms up. And then as we get towards the colder months, the amount of gas starts to ramp up again. So usually gas bills are higher in the winter because it takes a lot of gas to keep our houses warm. Okay, a little bit more than what it takes in the summer to cool them off. Okay, so it is natural to expect this pattern to repeat because every year our weather pretty much is pretty consistent. Our coldest months are usually at the end of January and in the beginning of February, and every year that seems to repeat. So we can just write that out here for why it has this shape. So we can just say the consumption of natural gas varies with the season. Okay, we can say one expects consumption to be high in the winter and less in the summer. Okay. So this is actually just for like all of Ontario. So I know for us who live in the southernmost part of Ontario, we actually probably have a higher gas bill in the summer than a lot of the other places in Ontario. The ones that are further up north, they definitely use more gas during the winter than they do in the summer. So, okay, so that's kind of a good reason why I would have that shape. Part B, do the data appear to be periodic? So, um, does this data appear to be periodic? So it definitely does. It seems to always have its peak at the start of the new year. Okay, we can always see it kind of always falls like around the February. So yeah, and I expect it to because the seasons are periodic. So it's not exactly periodic though. We can say the data is approximately periodic. Okay, the values don't exactly match from season to season, so or cycle to cycle. Okay, part C. Assume the consumption of natural gas in Ontario can be modeled using a periodic function. So that'd be kind of nice if we could come up with a function to follow through this graph. That's something we're going to learn how to do in this chapter. It says determine the approximate max value, min value, and amplitude of this function. So this question is not asking us to come up with a function. It's just asking us to find approximate max, min, and amplitude for the function. So those are very important, being able to identify these on the graph, because we will be using those to actually come up with the actual function that could go through here. So these are just going to be estimates that we're doing here because we know the cycles don't exactly repeat, right? So, all right. So I think I'm going to pick maybe for max value. Let's just kind of keep it simple. I know this month was pretty low in this one too. This one's also not finished yet either, but a few of them are a little over this line here, around 1.6 million. So why don't we kind of average this out as the max? So I'm going to draw a nice line through here. We can say that's the max. Okay, and the minimum is actually quite a bit easier to do. They're all like almost all of them look like they're really close to 200,000. So we're going to draw that through here. We'll call that the minimum. Okay, so our max is equal to 1,600,000. Minimum is equal to 200,000. All right, so that's the max value, the minimum value. Now we just need the amplitude. So a great way to find the amplitude is to do max minus min over 2. That's what I've done in the last few examples. So 1.6 million minus 200,000 over 2. That's going to be 1.4 over 2, which is about 700,000. Okay, so we could say, therefore, amplitude is approximately 700,000. That's a 7, yeah. Okay, 700,000 cubic meters. So we're going to write meters cubed because it is given to us here on the graph. Okay, cubic meters, we can write that as n to the exponent 3. Okay, so that's part C. D, it says estimate the period of this function. Does this value make sense? So looking at the graph, it looks like it happens every 12 months. Okay, which makes sense. Every year, the season repeats. So I'm just going to write that in over here. Period equals 12 months. Okay, and I'm just going to write it seasonal, right? That's the whole reason why this is happening. Okay, part E, estimate the domain and range of the function. Okay, so we're probably going to have to label this as T because it's time for our graph. And then I think I'll just label this lowercase g for gas consumption. Okay, and then we can go ahead and write out our domain and range. So for this graph, because we have specific data that's plotted, my domain should just be from start to finish. Okay. Notice I don't have a value though for January at 0. Looks like my first value is starting like at the end of January at February. So my domain, I want to go from 1 to 60. So let me change this back to E. Sorry, I kind of did the last few over here. This was C over here on the graph. Okay, so for E, we'll say the domain, we'll say T is an element of R, so the real number system. And we're going from month 1 and including it all the way to the last month, 60. And the range, this will be a little trickier. Gas consumption is an element of our, I kind of have to read the graph for this. So my absolute max value all the way to my absolute min value. So just to keep it simple, I'm just going to use these values here. Okay. So if I had a table that had the actual values in it, I would use those. So we'll say from here to here. All right. So let's go from, we'll go our minimum value, 200,000, less than or equal to G. Or sorry, so yeah, G is gas consumption's greater than and equal to 200,000 and less than and equal to 1.6. So we'll do 1,600, 0,000. There we go. Okay, and that would be our domain and range for that graph. Last question. Explain how the graph can be used to estimate the natural gas consumption in February 2011. February 2011, well, it should be pretty close to all the Februarys previously. So we have a February value here, 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 another one here, another one here. So it looks like if I had to make a prediction, I'd probably say 1.6. Okay. If you wanted to be really precise to make a prediction, this value, these are kind of high. What you could do is you could just take maybe the average of all of those, and that would be a little more accurate. Okay. That's what we'll say for F. To obtain a reasonable prediction, for February's consumption, take the average over 5 years. Okay, and I would make sure you read February like on the graph. So it works out to be the peaks on all of these, except for the last one. That's a January reading because it lines up exactly with 60. Okay, so time 0 is January, then the 1 would be February. All right, I hope you guys have found this helpful. This concludes our first lesson for Chapter 5, Modeling Periodic Behavior. I will see you guys in the next video.